Okay, good afternoon. We'll wait uh, for 2 to 3 minutes. Let's see if any more of your friends join. Else we'll start. Okay, we'll wait for 2 minutes more. Okay, we'll proceed. We'll proceed with you all only. Okay. So in this power system, okay, we were talking about your false. Okay, so we have seen these parametric value. We have seen these content. So in previous or session where we left, okay, we have talked about these things. Okay, where these equation were derived. Okay, we'll draw this particular part. Okay, okay, this system was designed and we have solved this. We have solved these equations. Okay, we have solved and we have seen this equation. We have also solved this equation. Okay, and we have concluded about these two for generator. So that is a sequence impedance for your generator, for static. Okay, for your sequence network, we have seen these things. Okay, we have also drawn this particular segment. Okay, this entire thing we have already covered. Okay, we have already covered in our section. Okay. We have also seen this derivations part. Okay, how to draw of without grounded. Okay, ungrounded network to your respective sequence network. Okay, how it will be satisfied. So we'll move ahead with this part. Okay, now the summary what we have got from this is only positive sequence network contain the voltage source. First thing is only positive sequence network contains the voltage source. Okay. Negative and zero sequence network do not contain voltage source. This is what we have got now. All the voltage sources must be represented by 1 per unit system. That is very necessary part. Okay, that the whole voltage sources must be represented by 1 per unit segment. Okay, the another segment is the conditions. Okay, the condition of neutral as no effect is representing, then the generator both are in positive and negative sequence network. Okay, now this means we'll see again once more. Okay, now this particular segment defines that the condition of neutral, okay, as has no effect, okay, in representing generator both in the positive and negative sequence. Okay, okay, the condition of neutral has no effect on this. Okay, this four terminology what we get. Okay, we'll see for your positive sequence network. In positive sequence network, okay, now sequence of positive in a given phase is R by B. Okay, okay, if we take, okay, that your this one is your original phase, that is your R by B. So in in positive sequence network, the sequence of positive, okay, the sequence of positive and original phase means this and this phase network are same. Okay, it will not change. Okay, the phase will not change as it would be over here. It will be similar for these two. Okay, so this is what it says. Okay, this is what it says about this particular factor. Okay, that is, okay, is R by. Okay, now the rotor is rotating in the anti-clockwise direction. So generator is generator will produce positive sequence network, that J E is equals to E, means whatever G part word is being represented will be represented as E. If rotor is rotating in anti-clockwise directions, then this generator will produce, okay, generator produce positive sequence voltage G equals to E, else it will not. Okay, now in negative sequence network, okay, the sequence of negative and original phase are opposite. Okay, original is R by B, so your negative would be your R B Y. Okay, means it is, if it is in the anti-clockwise, it will be in clockwise wise. Okay, as it is in anti-clockwise, means it will be in this manner. So the other format will be this. Like if you write R Y B and R B Y, okay, it will be in the same particular fashion. Okay, it will be opposite. In positive it is of same RYB, in this RYB and VM square anti-clockwise and clockwise direction. Okay, now it is not possible, okay, as it says, it is not possible, okay, that rotor will rotate in both direction at the same time. It's obvious. Okay, it will not be rotating at both the directions. Okay, now for producing negative sequence network, rotor should rotate in clockwise direction, which is not possible. So generator will not produce negative sequence, means your E would be 0. Now, it clearly says that this defined very clearly that it is not possible to rotate rotor to rotate in both the direction. Now if it is not producing, so for producing your negative sequence voltage, rotor should rotate in clockwise direction, as it is rotating in anti-clockwise direction in negative sequence network. Okay, so it has to rotate at clockwise direction, which is not possible. So generator will not produce negative sequence component. Now the main in zero sequence network. Okay, now a sequence are in same direction at the same time. Okay, this is possible only when rotor is stationary. Okay, means rotator is not moving, it is a stationary. When rotor is stationary, okay, generator will not produce zero sequence voltage. So zero sequence voltage means E will be 0. Now you got the answer. Okay, what will be the factor, or what will be the point, okay, highlighting, or what will be the segment that you have to highlight. Okay, that why. Okay, this is fine, this is all right. Okay, we have done with all the three, means why it is being produced and why, means what will be your E value. Okay, when G is being given, what will be E. Okay, when G is equals to E and G equals to 0 at your negative, okay, for 0 and negative sequence network, but for your positive sequence network, your G would be E. Okay, so we got to know how, why, and how it is the value what is being defined is being written. So okay, it may ask, okay, or in the question it may ask somewhere why it is happening or why it is not happening. Okay, now the condition 5. Okay, now this states the condition of neutral has got effect, okay, in the representing generator in zero sequence network. Okay, this is the same sentence that is being derived from that network. Okay, the condition of neutral. Okay, this is your part. Okay, neutral, okay, has got an effect in representing your generator, okay, in zero sequence. We'll see. Let's take this like if the neutral is ungrounded, source open circuited for your representation. Okay, in the representation, okay, in representation it shows, if it is ungrounded, it shows open circuit. It means your E would be 0. You will not represent at that particular point and it will be open circuited. Okay, if the neutral is solidly grounded. Okay, now this part, if it is solidly grounded, okay, as shown over here, see, it is solidly grounded, then your XZO in this particular would be your short one. Okay, it will be sorting to that particular point. Now the last particular thing. Okay, if the neutral is reactance grounded, see over here, okay, it is grounded through a reactance. Okay, it is, if neutral is reactance grounded, okay, then this 3xn should be added to xgo to get the total zero sequence reactance of the generator. Okay, whenever it is being grounded in this manner, your 3xn has to be added. Okay, so 3x to x to be added, okay, to get your total zero sequence reactance of the generator. Okay, why it should be added? These questions comes everywhere, okay, every time. So just be very frequent on just telling that, okay, why it is being added and why it is. Okay, so this was a question that was given to you. Okay, this is your format, that is YXL. Okay, I told we'll discuss in next class. Okay, xg1, x0, g01 shows a positive sequence. Now we have true positive, and I have added also show the negative sequence network and your zero sequence network. Okay, what has been asked now, based on the data collected above, okay, if it is without any grounded, so it will happen, your Z would be as it is and it will be open circuited. When it is grounded, okay, it will be Z2, it will be sorted. Now whenever it is passed by your Xn, okay, then this Xn would be your thrice. Okay, this would be your 3xn. Okay, so as we know that xn and gxg1 is your 0.01, so it will be a 0.01, 0.01, it will be 3 into 0.1, so it will be 0.3. Okay, so these are zero sequence network. Okay, this is a zero sequence network. Now positive sequence network. In positive sequence network, that would be generated by your G. It will be G2 is my G2, means all the generators would be present at that particular point in positive sequence network. Now in negative sequence network, as we know, E would be your 0, and over here it will be having E equal be your Z, or Z equals to your E. That's why generators have been placed over here with one per unit system as per the requirement what is been assigned or what is it be shown. Okay, now in negative sequence network and in positive, sorry, in zero sequence network, we know E would be 0 when Z is equals to 0, and over here Z is equals to Z. Okay, so in this also we'll have only your reactance value. No G value would be present in this particular fashion. So this was the actual thing that I wanted to show you up in recent particular period or time. Okay, now so next topic is your transformer representation. Okay, now so as we know, transformer, if we draw this particularly over here with nice conditions, okay, this is your generator, this is okay, this is your one bus bar, this is your second bus bar, okay, this is your transformer, and this particular point is your load, and this is your transmission line, this is your generator. If we see this particular domain is your transformer, right? So that will be seeing your transformer representation. Okay, how it can be represented and what it could be done in this particular fashion. Okay, so it's a transformer. So in this, your transformer is connected between 1 and 2. This is your 1 and this is your U. So this is a representation of your transformer. Right? Whenever it is in directly take it as a transformer. Okay. In the original network, okay, use in symmetrical fault, okay, which is used in your symmetrical fault. In the original network used in symmetrical fault analysis, transformer is represented as series reactance element. So in this particular point, your transformer will be represented as a series reactance element. Okay, this particular form only it will be represented. Okay, so you could see in this particular point, this is your transformer in per unit system. In this manner, it is being it is being represented. Okay, now for positive and sequence or negative sequence or zero sequence, your transformer representation would look like as the same, only the suffix numerator will be changed. Okay, like in this particular segment, you see is positive sequence segment, it is being transferred as same, and it is being written as a by x1. Okay, and negative sequence is also same and has been represented by x2. Whereas zero sequence network, the transformer is in the same manner and it has been written as x0. So these small changes are being observed in this particular fashion. It is okay. It's likely okay and likely good. Okay. Conditions to verify. Now this is most important. Okay. That conditions to verify. Now first, primary and secondary winding, that is your Y or delta. Thus is an effect or not. The first condition has its effect or has an effect or not. This is what is meant as the primary and secondary winding, that is the delta and star has some effect or not. So this has been asked. Now consider if Y connects neutral while delta. Okay, no. It is written if Y connects neutral will affect the winding. Okay, winding connections. Okay, or it may also do not disturb. Okay, if it affect you modify, otherwise leave as it is. Okay, now it says okay, if a firm gives a whole investment and all, it need to validate these things. Okay, now so in this one particular format is being asked and said or is recognized. Okay, that is if Y connection neutral. Okay, neutral will affect the winding connections of node. Okay, if its effect or we could write okay if there is winding which is connection on means it is affecting okay that so if it affect we modify means if they are affecting okay they are affecting then it will be modified or it will be as it is. Okay, now so what for the first figure it has been shown is your IV1, okay, that is your generation side, okay, that is the generation side, and second is your from transmission line side, okay, that's why the both changes are being made, that is your star and delta part, okay. So over here, I equals to 0, is no outgoing current. So in this factor, it is being connected into delta star, and it is also been connected into delta star. Okay, in this fashion. Okay, now second one is over here. See, this is your sorted part, this is your uh, transmission line, and this is your, sorry, this was the transformer, this is also your transformer. Switch diagram used to represent transformer 0 0 sequence. Okay, and so Y11 is primary switches, Y22 okay secondary switches, where 1 2 series sustained, okay, series switches, when 1 2 volt is the shunt switches. Okay, these are the land of, okay. So a series switch when transformer winding is Y connected, okay, and neutral is grounded. Okay, so series, okay, where switches when transformer, okay, transformer winding is connected and metal provided, okay, shunt switches we choose when transformer winding is delta cohesion. Okay, now a shunt switches closes when the transformer winding is delta. Okay, now when we see this, the IRO, IBO has been returned with a power factor of 80. Okay, now in second, let's see the changes. This changes and this changes. Okay, now it's 2 IRO is minus IYRO equals to 0. Okay, these are the switching one to clouds. Okay, based on the cloud scenario, this terminology was observed. Okay, now a series switches of when transformer winding is Y connected and neutrally grounded. Okay, this is what we caught. Okay, now a shunt switches closes when transformer winding is delta connected, right? Okay, so we'll see these things in upcoming future classes or not. Okay, in upcoming future class we'll see. So for now it is more than enough. We'll see in next class. Okay, thank you for joining. We'll see further. Okay, or we could do is let me see if we could discuss any of the point or not, or in the next class we'll discuss. We'll discuss in next class. Okay, we'll talk about your this switch diagram and all. Okay, so till over here you should be very peculiar. Okay, why your, what is your generator representation, what is your transformer representations. Okay, that these things you should be very well aware of before next class. Okay, we'll see these thing in upcoming short period or short classes. Okay, so there is not much to say or not much to talk about. We have done with, so we'll apply few of the students ratios are very low, so I thought of a plan. We will be applying this attendance segment and we'll see the daily performance. Okay, we'll provide you questions, or weekly performance will provide you the questions, and we go ahead and see. Okay, so yeah, that that would be more than enough for today. We'll also see a lot of things. We'll see what things we could do in this class. The first is your switch diagram. That is very necessary. Then representation of transmission line. We will also talk on this somehow. Okay. Now again, here is the driving point, diagonal point. Okay, these are the connections what we generally have or we generally see. Okay. I will solve problems tomorrow and seek on these problems. Okay. How it is being done and what other sequence terminology would assign to seek these kind of questions. Okay. So that will be very helpful. This is somewhat prepared notes, not with mine, yes, of course, of my friend. So will not get the exact same thing. Whenever you say, will also come with different categories. Okay. Yeah. So I am done with. You have open access. If you have any doubt, you may ask, or else we'll submit it. Okay, we'll provide all the notes, and we'll also have in next class we'll see lots of numericals. So if you want to ask any of the queries or any of the things, so you may directly contact me, and you could directly say that, sir, this is this party. Okay, what to say. Okay, we'll see in next class. Okay, just go and get remind and do uh, get some more other segment evolved. Okay, while solving or while doing things. Okay, so just get it solved and resolved. Okay. Yes, Rahul, you were saying something. Okay, so is it only in my class or you also face some other technology segment? Yeah, I know you are telling that your headphone is not working from last 2 weeks. So order it or buy it from local shop. Okay, you could order now. The local shops have been open, so don't worry about that. Till two you are allowed to buy or to roam it here and there. So you could easily get that. Okay, just get that and rest is okay. Okay. See ya. You may also text if it's not working. I will get it. I will read out and I will get it and we will could discuss it out in that particular fashion. Don't you worry about that. We'll see this thing in next class. Okay, from this summary and your transmission line and other segment. Okay, we'll see. Okay, okay. Thanks for joining. Yeah, and patiently listening to me. Okay, I'm ending this. Okay.